Welcome to the Energy Central Power Perspectives podcast, the show that brings leading minds from the energy industry to discuss the challenges and trends that are transforming and modernizing our energy system. And a quick thank you to H2scan, our sponsor of today's show. Now, let's talk energy. I'm Jason Price, Energy Central podcast host and director with West Monroe, coming to you from New York City. With me, as always, from Orlando, Florida, is Energy Central producer and community manager, Matt Chester. Matt, today we're joined by two guests working in a niche area of the power sector that is likely overlooked by the broader audience. The area we're discussing is hydrogen sensing for power transformers. Matt, for the non-grid engineers in the room, what have you dug up about this topic and market potential?
Sure, Jason. So again, today we're talking about hydrogen, but not in terms of the hydrogen energy economy. Instead, we're going to be hearing about the ways in which hydrogen gas has reared its head for the power sector for years, and the ways in which we can detect and use that type of sensing for the betterment of the utilities. Specifically, hydrogen gas may develop over the lifetime of a power transformer as a way that highlights that transformer's relative age, health, and status. So given our utility community these days are seeing multi-year waits between placing orders and receiving new transformers, any information we can get on transformer health and proactive steps that can be taken to improve and elongate that lifetime has really become a necessity.
Yeah, that's a great background, Matt. Really appreciate it. And clearly, this is an important aspect to grid operation. And as we continue to electrify and add more load to the grid, we are, in essence, adding more weight for the grid to support. We are joined today by two key professionals from H2scan Corporation. First, we have Leon White, who is the company's VP of Transformer Sales and Business Development. Leon, welcome to the podcast.
Thank you, Jason. We're happy to be here.
And also joining us is Leon's colleague, Bill Whitehead, H2scan's International Accounts Director. Bill, welcome to the Power Perspectives podcast as well.
Great. Thanks, Jason and Matt. Glad to be here.
Gentlemen, welcome to the show, and let's get started. So let's start with the basics. You're dealing with hydrogen, but let's just be clear. We're not talking about hydrogen in the form of gas as it is as an energy source, but rather hydrogen detection in power transformers, as Matt had, given us a background on. Give us the basics of why this is important. How about if you start with a little of the science? Leon, you want to start with this?
Sure, thank you. So most transformers, larger transformers and small transformers, whether they're on a pole near your house or in the front yard or in a substation, most are filled with mineral oil. And when transformers get sick and things start happening inside the transformer, temperatures inside can reach usually 150 degrees C or hotter. And when you start seeing those temperatures, the oil starts degrading and starts generating hydrogen and other combustible gases. And so those are bad things to have in your transformer. Sometimes it's due to a short-term issue. Sometimes those things can generate a little bit of hydrogen, but by monitoring the hydrogen in real time, you can get an idea for the real-time health of the transformer. So if you're continuously generating the gas, that indicates that there's an active fault in the transformer and your transformer could be heading to failure.
Bill, anything to add to that?
I guess the term is called pyrolysis, and basically it's the breakdown of insulating liquid into hydrogen gas. And what happens is basically as you have higher temperatures with the hydrocarbons, it breaks into these smaller molecules. So the science is temperature to the mineral oil causes the breakdown of that material into gases.
So let's just go into the natural process a little bit more, because now we're going into the physics and chemistry of what's going on here. So H2, hydrogen, is produced inside a liquid-filled transformer under abnormal conditions, and your technology monitors for any indication of that. So this is really both an asset management and a safety play. Is this correct? Maybe Leon, you want to start?
Sure. So from an asset management standpoint, as you indicated earlier, transformers have gotten more expensive in recent years, doubling in price in just the last few years, and lead times on many transformers today are 2 to 3 years. And so that's increasing the criticality of the existing transformer fleet, since you want to take care of the assets you have and hopefully not have to replace them. And so from a safety standpoint, historically, utilities will take oil samples on large transformers once a year. And if they see an issue, they will send people out to take more samples. And so they might move to quarterly or monthly sampling. And so effectively what you're doing is you've got a concern with your transformer, and you're potentially putting somebody in harm's way, because if that transformer fails while somebody's there, is typically not a good thing to happen. And so with online monitoring, again, you're looking at the real-time health of the unit and communicating that data back remotely. So not only are you protecting your employees from being around equipment that may have issues, but you're also protecting public and protecting your resources by looking at the online data to see if there's a problem. And if there's a problem, look at changing out the transformer or doing maintenance on the transformer on a scheduled basis versus waiting for the transformer to fail. And then you have a fire drill of everybody running around trying to figure out where's the spare and what do we need to do to get this thing back in service and all that kind of thing. So it's always better to do things on a scheduled basis versus a unscheduled basis. And not only are you looking at the safety of your employees and protecting your assets, you're also looking at the public safety and so forth, because a small percentage of transformer failures actually do end catastrophically, and those are the ones that make the news, and those are the things you definitely want to avoid.
Bill, when we had the chance to chat before this episode, you mentioned that this area has been on a multi-decade journey. So can you give us some insight into that and how it's shaping your business today? And more importantly, what are the common ways to address monitoring today? And why would something of such importance not be required?
Yeah, no, I'll tell you, it's been a long journey here with so many years ago, when the transformers looked at, basically these manual oil samples were taken, almost like taking a blood test on a person. Send it to a lab and you do an analysis to determine, if everything's okay or not. Same thing for transformers a long time ago. You take a manual oil sample, you send it to a lab, you identify the combustible gases that are present in the oil, and you decide, if everything's okay or not. And then from there, the next thing that happened was hydrogen sensing technology was developed so that you can actually put a sensor on a transformer and do real-time monitoring of the hydrogen. This was very important at the time because what it did was it allowed for some type of an alarm trigger or something to happen, and it would queue up the maintenance team to go out there and perform another manual sample before the normal annual cycle, let's say. And then from there, if we move forward a little bit sooner, maybe in the 2000s, all of a sudden the multi-gas sensors were developed and created. These were needed for critical transformers at the time, but there was a big marketing push to put multi-gas sensors on pretty much all large transformers. Even though it sounds like a great idea, what ended up happening was that these monitors required heavy maintenance and never really lasted that long. Transformers' life expectancies is about 40 years, and these multi-gas monitors really only lasted for about 10, with pretty heavy maintenance after 5 years. So kind of a big lesson was learned over time. And so now people are kind of stepping back and saying, why don't we get back to the basics again and just look at monitoring maybe a key gas in these transformers. And then when it's the right time in the life of that transformer, then maybe it makes sense to put a multi-gas sensor on there. And then now let's fast forward in the last let's say 5 years. I call it the disruptor situation scenario, where the GridScan 5000 was developed, hydrogen specific, 10 plus years of life expectancy with continuous accurate information that can be installed on a single valve practically anywhere in a transformer. So what's changed over this multi-decade journey was kind of life lessons of online VGA systems, the true life expectancies of these and the maintenance costs. And then all of a sudden the disruptor came out, which said, hey, let's solve a problem with long life expectancy from a hydrogen sensing technology that can be deployed pretty much on any size transformer because of its low price point. And Leon, I'll share as well, is that today most of the time when you put a sensing technology on a brand new transformer, you really don't need something so sophisticated. You need something simple. And then as maybe 10, 15, 20 years go by, all of a sudden you might see some symptoms that justify using a multi-gas sensor.
Yeah, I can imagine these being busy times for you. Before we continue on to the next question, Leon, was there anything you wanted to add to Bill's response?
Yes, thank you. About 20 years ago, around 2001, as Bill indicated, the industry came out with multi-gas monitors. And so these monitor most of the gases you see on your lab analysis when you send an oil sample to the lab. And most of the marketing in the industry has indicated to customers that you've got to have multi-gas, you've got to have multi-gas. And so everywhere around the world we go, we hear that you've got to have a multi-gas monitor. And we've really lost the discussion about hydrogen because all the marketing has really pushed the multi-gas agenda. And as Bill indicated, there are transformers you absolutely want multi-gas monitors on: your large critical transformers, your generator transformers, SIC transformers. But for the rest of your fleet, in general, utilities see about a 1% to 2% failure rate of their power transformers. And with the expensive multi-gas monitors, it's difficult to apply those to a large number of transformers. So if you've got a fleet of 1,000 transformers and you're going to put multi-gas monitors on 20 of them a year, you'll never get there. Whereas with hydrogen monitors, you can put those on. And the beauty of, as Bill indicated, our technology, solid state technology that lasts 10 plus years with no maintenance, is people put it on and they don't have to worry about it. They see that the monitors identify an issue, and when an issue is present. Otherwise, the transformer owner doesn't have to worry about maintaining the monitor more than they're maintaining the transformer.
What's really interesting, Leon, as we've been doing this for a long time, we went from selling the single gas units that made a lot of sense for sure, and then we started selling multi-gas systems in the right places for the right reasons. And then it seems like we're coming back to H2scan, and we're getting back to keep it simple with the single gas monitors, and it's really resonating with everybody around the world, which is amazing. And I think the challenge was until the GridScan 5000, the only single gas monitor out there was a composite gas unit, and you couldn't tell the difference between hydrogen or carbon monoxide. And with that, people really didn't 100% trust those composite sensors. And now with our GridScan 5000, I think it's kind of really changed the game.
I'm curious how this is being addressed around the world. So, for example, what are the Europeans doing to maintain transformer uptime and safety? And furthermore, I saw an exhibit at Distributech in San Diego on the Ukrainian grid. Is there a risk that transformers can be weaponized?
Okay. Well, you got a lot in that question there, but we'll start with what's going on in Europe, elsewhere around the world, and then we'll talk about what people are doing to protect their transformers from a physical element. And so in Europe, as the world knows right now, there's a lot of stuff going on in Ukraine. A lot of the grid is being targeted, and the world is coming together to help Ukraine keep their grid intact and keep the lights on. And so that's a challenge for them. Also, about 40% of the natural gas has been cut from Russia to the rest of Europe, and that's causing people to move from utilities wanting to move people from natural gas heat to electric heat, which is putting further stress on the grid. And then also with the environmental proactive electric vehicles and so forth rollout, those things are all coming together to put additional stress on the grid. And so the distribution utilities in Europe are actually starting to enact online monitoring requirements for distribution assets, including transformers. And so they're looking at voltage, current, temperature, and we're working with some of the companies over there to install hydrogen sensors on critical transformers as well. So things that people don't think about, they think about their electric car, how great it is. They can plug it in, charge it in 28 minutes. And you don't really think about how much power is consumed when that happens. a lot of current and the 40-year-old grid that charging station is connected to. And so you're looking at potentially overloading a lot of transformers, definitely putting loads on the transformers that they weren't designed to take. And so utilities are starting to realize that monitoring those assets in real time is becoming more and more important. And there's been a lot of talk about the distribution grid being used in ways that it was never designed for. So you've got distributed generation with solar and wind generation connected to distribution and load flows that, again, it was never designed for. So all these things are coming together to make people realize that monitoring those assets is becoming not only more necessary, but there's also technologies like automated meter reading and other distribution automation, communication systems and so forth that utilities are putting in that are allowing the technologies like our H2scan 5000 to be installed on remote transformers and get the data back and be able to make decisions on those remote transformers that they never had a vision into the real-time health of those assets of the past. And so we're seeing that in Europe and other places of the world. We're also seeing China has done a lot recently. They've been really growing a ton of their electrical system, and there's a lot of growth in China right now. And they're doing all kinds of things, including things like monitoring high voltage bushings using our sensors that most bushings don't have a tap that you can do that with, but that's an application that is very popular in China right now, and not only monitoring the main tank or the load tap changer in the transformer, but also monitoring the hydrogen and the oil that's in the bushing. And so we're seeing all kinds of interesting things around the world. As far as the protection of transformers, Bill and I were at a conference last week, and there was a paper concerning ballistics protection of transformers. And so these are special coatings that you can put on transformers to protect them from certain caliber of bullets and so forth. And, there's been a lot in the news recently about somebody taking shots at the transformers at Duke. And, prior to that, there were similar incidences in California and other places. And so it's really highlighting the criticality of transformers. And, especially today, if you have a number of transformer failures in the same location, it may be difficult to get the lights back on. So, all these things are coming together. And the beauty is that technology is allowing disruptive technology like ours to enable things that have never been possible in the past. Bill, did you have anything to add to that?
Yeah. What was very interesting, I'll start at the back. Can you weaponize transformers? I think basically, back in 2006, the NERC-CIP was born, North American Electric Reliability Corporation. They call it the Critical Infrastructure Protection. And basically, it was recognized way back, a while back, that the electrical grid infrastructure was vulnerable to terroristic attacks, and we were very vulnerable. And so just like Leon mentioned, there's UL ballistic ratings now for transformers. These remote transformers, you use resin-type bushings as opposed to liquid-filled bushings, so that if it did take a ballistic, it wouldn't just catastrophically fail. Also, high walls being built around remote transformers, so you don't have a clear shot at the transformer. So I think, when we say weaponize transformers, I guess we're really saying weaponize the taking a transformer out of service. And so I think that's recognized around the world. And there's a lot of things happening to protect or try to help prevent those things from happening. Leon mentioned a lot of things happening around the world. There's a lot of standards out there on how to monitor or to analyze the condition of a transformer based off the liquid concentration of the different hydrocarbon gases that are formed. And so a lot of those things are coming to the front. Seagray right now is really pushing on how to make a decision on which type of online DGA or dissolved gas analysis system should you have on different size transformers. So all of that's happening right now. So, I think what's happening around the world is that everyone's recognizing the importance of gas monitoring on transformers. And I think there's some other questions we have here coming up that talks about what's changed in the trends and markets that we'll talk about. to kind of reemphasize about extreme weather events and overloading and increased harmonics due to electric vehicles and renewable energy. So there's a lot of things happening in our world that's really pushing the importance for hydrogen monitoring of transformers.
That's excellent. Of course, the energy sector is undergoing vast changes that go well beyond these sensors and transformers. So I'm wondering if you can talk to how those big picture changes in the power industry trickle down to your area of focus. As utilities seek to decarbonize, as grid liability continues to take center stage, as new concerns like cybersecurity and supply chain shortages grab headlines, does that impact what H2scan does or can do with the technology? And Bill, why don't we start with you?
Yeah, no, absolutely. Like the big picture changes, we were mentioning some of them before. I guess I'll put them in some groupings of these big trend changes that are happening around us today. One is we're noticing extreme weather event changes happening across the planet. It's really impacting, when you turn the heater on or when you turn the AC on. So those things are changing. The climate's changing for that. System fault. It's really interesting. Because of we're adding renewables, we're shutting down fossil power plants, we're adding solar, wind, we're adding EV. What's happening is we're getting, electricity going in different directions that we haven't seen before in the history of our power grid. And so what's happening is sometimes you have system faults that occur that weren't there before. And so we're mitigating those risks, but those things are actually causing some negative effects on these transformers. Emergency overloading is starting to happen. If the sun's not shining or the wind's not blowing, all of a sudden now you're having to, push power a little bit harder through maybe a transformer or a location that it didn't expect. And then increased harmonics. And what I mean by that is we have a lot more power, switch mode power supplies happening out there because of electric vehicles and solar arrays or solar panels on the house. And so these harmonics that never existed down there are there. And these harmonics, actually what they do is they cause heating effects in these distribution transformers. Again, that's never been seen before. So a lot of these things are happening at the moment. And so with all these effects, when we used to look at the life expectancy of a transformer, you're looking at 40 years. What's happening with these new events are actually decreasing those life expectancies of these transformers. So maybe they're 30, 35 years. And so it's becoming super important with our technology, just to monitor the hydrogen health so that if you are having these overloading conditions or you're having some type of harmonic events, you really want to know if the transformer is seeing the negative effects of what's happening to it. And in the past, you would monitor maybe the current and temperature of those transformers. Well, current and temperature may be fine in that transformer, but it's only when hydrogen is being produced when there's a negative scenario happening. As we continue to improve on our technology, it's just going to get better for customers out there. So we're looking at miniaturizing our hydrogen sensing technology. And so as we get it, to a point where we can get it smaller, less expensive, it becomes easier to deploy across a fleet of transformers.
Let's look ahead. What comes next? What are your customers looking for and asking regarding, this technology? What's the vision for the next 5 years in this space? And what can you tease out that will get our listeners particularly excited for things to come?
Right. So we have a lot of things that we're working on. We've just this last year, we've pretty much doubled the size of our engineering staff. Lots of new applications. We have sensors that work in a lot of environments, but there's always other applications that we're asked for that we don't have the sensors for those specific applications. In general, everybody's looking for smaller, lower power sensors. There's a big push in the utility industry for IoT type devices. So be able to put a sensor on a transformer, say at a wind farm that has 200 transformers, but may not necessarily, it's kind of funny. You've got 600 volts or 34 kV at a pad mount transformer at a wind farm, but you don't have 120 volts to run a sensor. And so those kind of challenges, people want to have a low cost solution for, say, a solar, you put a small solar panel on the monitor and communicate the data back daily over an IoT system. And so those are the exciting things we're working with customers on. The sensors we have today will work, but there's always enhancements and smaller, lower power, lower cost sensors that would are really needed in the industry. And so those are the things we're working on, as well as a variety of different applications from fuel cells to electrolyzers. There's utilities that are in the process of right now of installing hydrogen generation. And so not only are you concerned about hydrogen leaks and monitoring for those leaks in that situation, there's other applications like most electric substations around the world have lead acid batteries, the battery backup for the substation. And when those batteries charge, which is continuously, it generates hydrogen. And so if there's been incidences of large utility scale battery storage systems. There was one in Arizona where a battery failed and a firefighter went to open the door. The whole place blew up and sent 4 people to the hospital. So monitoring for hydrogen in those applications is becoming more and more popular.
I appreciate you both for turning an important and complicated and challenging topic into something that's understandable and relatable, both for me and Matt, but also for our audience. So much appreciated and sharing your insight and wisdom in this area. We now are going to pause and pivot to what we call our lightning round. We are going to give you the last word, but we first want to learn a little bit more about both of you, the person rather than the professional. So we have what's called our lightning round, where we ask you a series of questions and you hold your answer to one word or phrase. We'll start with you, Leon, and then followed by Bill. So gentlemen, are you ready?
Yep.
Yep.
All right, do it. All right, so Leon and then Bill. Your go-to snack at the movies?
Popcorn.
Same, popcorn.
If you were granted a superpower, what would it be?
Fly.
Time travel.
Favorite way to spend a day off?
Family.
Hiking in nature.
Who is your role model, or who has had the biggest influence on your career?
That's a tough one. My first thought was Bill, because he trained me on hydrogen monitoring, but I'm going to go with Brian Sparling, who taught me a lot more about transformers.
For me, it's between Elon Musk and Simon Sinek. As a role model, I think those are very interesting philosophies, but those guys have. And I'll tell you, it's amazing because as far as my career, it's also Brian Sparling. And me and Leon did not talk before that. That was definitely one of the biggest influences in my career as well.
And lastly, what are you most driven by?
I always try to do the right thing and use common sense in everything I do. People try to overcomplicate things, and I want to boil it down. And that's where hydrogen for me is going back to basic transformers. So it's a common sense approach, and in my mind, it's definitely doing the right thing.
In mine, I put simplicity and factual data.
Mm-hmm. Well, fantastic to both of you. Thanks for letting us tap into a little bit more about who you are, and thanks for being great sports about this. So, like I said, I'm going to give you the final word. So we'll start with Bill. What's the message you hope our listeners take away from today's conversation?
Yeah, well, first, thanks, Jason, Matt, and I really appreciate this opportunity. I guess maybe the biggest importance or the message I'd like to get across is hydrogen sensing technology and power and transformers is super important. And that, hydrogen gas, it really is a way to ensure reliability and safety in transformers. And so as we evolve, as the world evolves around us, I think it becomes more and more clear that some basic, simple hydrogen sensing technologies can really make a difference with managing transformer fleets.
And I don't have much to add to that. The only thing I would like to add is if people are interested in learning more and analyzing their situations, I wanted to let everybody know that we are available and more than happy to work with folks to help them improve their transformer reliability programs.
Oh, no doubt the Energy Central community will be actively following up with questions, and we certainly encourage them to hop on the channel to post their questions. And in the meantime, Bill and Leon, I once again want to thank you for sharing your insight with us on today's episode of the podcast.
Thank you.
Thank you.
We also want to give a shout out of thanks to the podcast sponsor that made today's episode possible. Thanks to H2scan. H2scan Corporation specializes in the design, development, and manufacture of industrially hardened hydrogen sensors. The company was founded in 2002, based in Valencia, California. H2scan's products are used in various utility industrial applications, including power transformer health analysis, substation battery room safety, and process gas streaming monitoring. The sensors and analyzers are designed to provide accurate and reliable measurements of hydrogen concentration levels for 10 plus years without requiring calibration. H2scan's technology is based on advanced material science, and the company is committed to providing innovation solutions to help customers improve their process and operations. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com, and we'll see you next time at the Energy Central Power Perspectives podcast.